So in this video, we're going to take equations of parabolas that are in general form. We're going to put them in standard form, and then from standard form, we're going to find specific information. So let's go ahead and jump right into problem number 1. So we have this general form equation, and what we want to do is put it in standard form. So what we're going to need to do is collect up, in this case, it's x that's being squared. So we're going to collect up all the x terms on the left, throw everything else to the right, and we're going to complete the square. All right, that will put this in standard form for us. So we've got x squared here minus 6x. I'm going to leave my space to complete the square. The 4y and the 17 are going to go ahead and move over to the right side. So negative 4y and minus 17. All right, to complete the square, we're going to do half of negative 6. That's negative 3. Square it is positive 9. So I'm going to add 9 to the left side, but to balance, of course, I have to add 9 to the right side. Now on the left side, I'm going to go ahead and rewrite this as x minus 3 squared. On the left side, no, that was the left side. On the right side, let's go ahead and clean this up a little bit. So negative 4y minus, what is that, 8? All right. And then I'm going to factor out whatever value, whatever coefficient is in front of y, I want to factor that out to get it into my standard form. So I'm going to divide out a negative 4, so y plus 2. All right, so now that it's in standard form, there are certain pieces of information I can just automatically know. I know my vertex is going to be positive 3, negative 2, and I know my focal distance is going to be 1. So remember, vertex is whatever is attached to x and y. Remember to flip its sign. And then for the focal distance, take the absolute value of this number in front and divide it by 4. So absolute value of negative 4 is 4. Divide by 4 is just 1. Now, I'm a visual person, so for me, knowing this vertex and this, focal distance is great. But if I need to find the actual focus point, the directrix, I need to see it. So I'm going to take just a quick second and graph this thing, all right, or at least sketch a graph. So I know my vertex is 3, negative 2. This is x squared and negative, so this means this is going to be concave down. So my focal point is going to be 1 point lower than my vertex, and my directrix is going to be 1 point higher than my vertex. So if I put this into context, all right, this was positive 3, this was negative 2. So if I go 1 point lower, that's going to be negative 3 here. If I go 1 point higher, that's going to be negative 1. So let's put it all together here at the end. We need it says find the vertex. We actually did that already. All right, so vertex is going to be 3, negative 2. All right, my focus is this little green point right here. So it's positive 3, negative 3. All right, so 3, negative 3. My directrix is the line y is equal to negative 1. All right, horizontal lines are y is equal to. Vertical lines are x is equal to. And then it says find the length of the latus rectum. All right, so latus rectum. Remember, that is 4 times your focal distance. So if you know your p-value is 1, remember that's your focal distance, multiply it times 4, and we get 4. All right, so that's all the information that we were asked for in problem number 1. Now, if you can find that information without drawing yourself a picture, you absolutely do not have to do the picture. I just find it to be much easier. All right, like I said, I'm a visual person. I need to see it. All right, problem number 2, I believe, asked for the exact same information. Vertex, focus, directrix, yep, same information. We've just, of course, changed the equation. So problem number 2, we've got y squared this time. So in this case, we're going to go ahead and hold y squared and the 6y on the left side. Give yourself a little space to complete the square. And then the other two pieces, the x, so negative 12x is going to move over as a positive 12x and minus 21. Okay. Let's go ahead and complete the square. I'll get it right eventually. All right, half of negative 6 is negative 3. Negative 3 squared is positive 9. What I do to the left side, I need to do the right side. All right, left side, I can factor into y minus 3 squared. Right side is going to be 12x minus, I feel like that's going to be 12. It is, okay. All right, so y minus 3 squared. Now, again, when you have this right side here, I need to factor out whatever coefficient I have. In this case, it's 12. So let's see, x minus 1 is left behind. All right, so information that we know. We are looking for a vertex. Let's see, what else do we have here? A focus, a directrix. There we go. And latus rectum. Okay. So now that we've got this in standard form, we can absolutely pull the vertex. Now be careful. Remember, the x value comes first and then the y value. I say that as a remember because, you know, I've only made that mistake a couple of dozen times. All right. So positive 1 and positive 3. Focal distance here is going to be, what is that going to be? That's going to be 3. All right. It's the absolute value of 12, which is 12 divided by 4. Focal distance is 3. All right. So if you can figure out everything without doing a little graph, great. Go ahead and jump right to the focus, the directrix, latus rectum. I can't. I need to see it. So let's do a quick little graph for me at least. Let's see, vertex is going to be 1, 3. So there's 1, there's 3. All right, this was y squared and positive, so this thing's going to be opening to the right. Okay, so something like that, which means I'm going to have a focal point 3 units to the right of this vertex. So I want to go 3 units to the right, which would be 4. So that means my focus is going to be 4, 3. All right, my directrix, I need to go 3 units to the left of my vertex point here. So that would be somewhere back over here. 3 units to the left would be, I believe that's negative 2. So let's see, directrix would be x is equal to negative 2. And the length of the latus rectum, take your focal distance, multiply it times 4. And the length of the latus rectum would be 12 there. So anytime you're talking about distances and or a length, those are going to be positive. So just be careful with that. Okay. So let's take a look at problem number 3 here. We've got this equation, x squared plus 4y is equal to 4. It's a really small equation. I'm going to go ahead and move that down here. Let's see here. So x squared is equal to negative 4y plus 4. Yep, okay. So now I'm going to do the same exact thing, but there's nothing to complete on the x squared portion. There's no other x term, so I just need to factor out that negative 4. So I believe that's y minus 1 there. All right, so let's see. I'm going to make my little list of things that I need. I need a vertex, which actually I can figure out right now. So 0, 1 is my vertex. Let's see, do a little picture. Actually, let me list out the rest of these things. Focus, directrix, and the length of the latus rectum. There we go. Okay, so I know my vertex is going to be 0, 1. This is x squared, but it's negative, so it's going to be opening down. Let's see, focal distance here. I want the absolute value of negative 4. So 4 divided by 4 is just going to be 1. All right, so let's see what we've got here. That's going to put my focal point 1 unit below the vertex. Well, that means the focus is 0, 0. That's the origin, okay? Directrix, I'm going to go 1 unit above the vertex and draw myself a little horizontal line here. So that's going to be y is equal to 2. And take your focal distance, multiply it times 4, and you will get the length of the latus rectum is 4 units. All right, so that's number 3. Let's see what we can do here for number 4. The exact same process. All right, but this time we've kind of got things split up already. So let's see, x squared minus 2x. There's going to be a completing the square piece there. So 4y minus 1. All right, let's go ahead and zoom in on that. Half of negative 2 is negative 1. Negative 1 squared is positive 1. So I'm going to have a plus 1 here, plus 1 here. So that would give me, factoring on the left, x minus 1 squared. The negative 1 and the positive 1 are just going to cancel each other out there, so I'm just going to have 4y. All right, so all of the same basic information here, vertex. And the vertex here is going to be 1, 0. All right, it's what's attached to x here, which is negative 1, but it's flip its sign. And then what's added to y, well, there's nothing added to y, so it's 0. All right, eventually I'm going to need to focus. I'm going to need a directrix, except I can't spell it apparently. Directrix, put the x at the end, and latus rectum. Okay, that's supposed to be an M. There we go. Okay, so I'm going to do a quick little sketch here. Let's see, 1, 0. This is x squared and positive, so it's going to be concave up. So I'm going to move, well, let's see, focal distance here would be 1. So I'm going to move up 1 to get to my focus point, so that would be 1, 1. I don't know why I'm trying to write 1, 0, so it's 1, 1. All right, directrix, I'm going to go 1 unit below the vertex. And that's going to be my horizontal line there. So y is equal to negative 1. And take your focal distance times 4, and that's the length of the latus rectum, so that's 4 units. So there's all of our handy-dandy information there. All right, problem number 5, which will be the last one we'll talk about on this video. It's going to be the same thing that we've just been doing. It's a little out of order though, so let me go ahead and clean it up to make it into an order that we like. So there's going to be y squared minus 6y. So keep all the y terms on one side, move everything else to the right side here. So negative 8x and minus 1. Let me go ahead and zoom in there. Let's see what we've got here. I need to complete the square. So if I have negative 6, I need to add 9 to complete the square for that one. Add 9 to keep the balance of the equation. So then complete the square. We've done that. So let's factor on the left side. So y minus 3 squared is equal to negative 8x plus 8. So y minus 3 squared is equal to, factor out that negative 8, so x minus 1 is left. Okay. So now let's talk, our vertex is going to be 1, 3. Remember, order matters, so it's going to be x then y. It's not the order of the equation, so don't read it left to right. It's always whatever is attached to x, then what's attached to y. So let's go focus here, directrix. Spelled it right this time, go me. All right, latus rectum. And I really shouldn't be that proud of it because it's written in the directions of every problem. All right, one other quick thing I'm going to make a comment on, and that's my p-value. My focal distance is, in this case, 2. All right, let's put a little pretty picture to go with this problem here. We have a vertex of 1, 3. So 1, 3, okay. This is y squared and negative, so this means it opens to the left. So I need to count 2 units to the left of my vertex, which will get me a focal point of -1, 3. I need to count 2 units to the right of my vertex, and that will give me my directrix. So that would be 3. So x equals 3. And last piece is to take your focal distance of 2, multiply it times 4, and you will get the length of the latus rectum, which would be 8. All right, I'm going to go ahead and close this video, and I will do a second video for parts of the second page. Any of the problems that are like this, I will probably skip and just put in the key. But if you have any questions or concerns on anything that I've covered in this video, please send me a message in either Canvas or send me an email.